Dear students, hello. Hope you are all doing well. Today we will continue our second lesson about wave. I hope that last lesson was clear and good. First, we will start with making a quiz. We have a small quiz, wave terminology. We have some new words. We have some missed words, which we have to find. And I want you to be more accurate about them. So let's start. First. We will start with the first one, wave transfer. So here we have four choice. The words of choice: vibration, particle, amplitude, energy. So I think you are thinking which word to put here to choose. So waves transfer without the transfer of matter. I will choose word energy for the first question. And in the second part, in missed word waves, the vibrations are at 90 degrees to the direction of propagation. So for the second part, as a missed word, we have the words transfer, longitudinal, polarized, and sound. Dear students, which words you think is suited here? So I will choose here the word transfer. In transfer waves, the vibrations are at 90 degrees to the direction of propagation. Yeah, I think it sounds good. As a third, electromagnetic waves are. So missed word and wave. Look, we have three choices: transfer, longitudinal, and mechanical. So at this point, we have to remember the definition of transfer and longitudinal. So electromagnetic wave, I will choose here transfer waves. At the end, when we will finish all these questions, we will check them. So for the fourth missed word, waves cannot transfer energy in a vacuum. Let's see in a missed word what we have: electromagnetic, mechanical, transfer. So I think you are now thinking which word will be suited here. For the fourth, I will choose mechanical. Mechanical waves cannot transfer energy in a vacuum. Let's continue with the fifth question. The amplitude of a wave is the distance from the missed word to the crest of waves. As the missed words, we have trough, peak, equilibrium position, and wavefront. The amplitude of a wave is the distance from the equilibrium position to the crest of the waves. Let's see for the sixth question. In missed word waves, oscillations occur in one plane only. In transfer, longitudinal, light, polarized. So for the sixth question, I will choose the word polarized. In polarized waves, oscillations occur in one plane only. So the last question, let's see, sound waves cannot be polarized because they are. The missed words are powerful, reflected, longitudinal, and transfer. So for the seventh question, I will choose the word longitudinal. As you see, dear students, we answered for all the questions. And now let's check what are the results. How is our result? So as you see, when I click to the C, so we can see the result. We did really good. So 7 out of 7. I think you will also see for this part, and if you will have some questions, you will ask me later. Okay, we move forward. We move forward, dear students, and see what we have next. Okay, give me a minute. So here we have the picture of different waves. We may classify as first, second, third, and force. So you can see that the wavelengths, the frequency, and the amplitude of these waves are different. So, but when we add them, we have as a result, let me here write, as a result, we have some different waves. So I think you can see from the picture. So if we add the waves with different amplitude, with different frequency, with different wavelengths, we will have also different type of wave. And dear students, we have another new key terms, another term which is called period and frequency. So waves can be drawn to show displacement as a function of time rather than distance from the source. So here we can see the wave, and we have a graph. In the graph, here we have the displacement, here we have time, so displacement time graph. And we have the term which is called period. Look, the period is a time taken for a wave peak to travel to the distance of one wavelength. So I think you have to remember that two peaks here will form one wavelength. So the period is the time taken for a wave peak to travel the distance of one wavelength. Let's continue. We have another term, the frequency. The frequency is a number of complete cycles per second. It is measured in hertz. So where 1 hertz is one complete wave per second. Dear students, we have relation between wave and, we have relation between period and frequency. So let's see what is the relation between them. So you can see here, frequency is equal to 1 over period, or we may change. Period is equal to 1 over frequency. So period is equal to 1 over frequency. We may change these two terms. So I think you understand this part. And dear students, we have another term which is called wave calculations. So we have some worked example which we will solve together with you. And here we have a formula. Please pay attention for this formula. Wave speed, it's like velocity. Let me write V is equal wavelength. We know it, the symbol wavelength times frequency. So here, dear students, you saw that we have a new formula for wave speed. To find the wave speed, we always have to multiply frequency with wavelength. So let's move forward and see which example do we have. So first example, please, first let's read the question. What is the speed of sound waves that have a wavelength of 34 millimeter and a frequency of 10,000 hertz? So dear students, I will give you some second to think about this example. How can we solve? So please think a little about it. And I think let's start together for solution of this example. So dear students, first of all, let's write what is given to us. So the given here in this example for us, first let me divide my whiteboard into two parts, so having much space. So the given first, the first thing which is given to us is wavelength. Wavelength is equal to 34 millimeter. Then the frequency is given to us, f is equal to 10,000 hertz. Then we have to remember the formula, V is equal to wavelength times frequency. Please, while solving this problem, don't hurry, dear students. I want you to pay attention for the units. Look, here we have the unit of wavelength 34 millimeter and unit of frequency is 10,000 hertz. I think frequency is okay, but if you look for wavelengths millimeter, we have to convert it into meter. So 34 millimeter is equal to 0.034 meter. Dear student, now we can make a calculation. So velocity is equal to wavelength 0.034 times 10,000. And here we have the result as 340 meter per second. So dear students, you can see here as a solution of our example. I may say that it's not so hard and we get the result. So let's go back for our question. Let's move for the question. So sorry. So here let me clear all the drawings. So let's see together for the solution. Yeah, here we have the result, 340 meter per second. So the solution which we made with you is okay. We have some more question, dear students. Let's look for the second question. So let's first read the question, what is asked, what is given. We have to be clear about that. What is the frequency of visible light waves of wavelengths 500 nanometer traveling through glass at 2 times 10 to the power of 8 meter per second? So let's again open our whiteboard. So we move for our whiteboard and I will divide the whiteboard into 2 parts from the middle and then we will start solving with you. So first, let's write what's given for our example. So again, we have the wavelength is equal 500 nanometer. Dear students, you pay attention for the unit. So we have to convert it into meter. 500 nanometer, if we will convert it, it will be equal to 5 times 10 to the power of minus 7 meter. Because I think you all remember that 1 nanometer is equal to 10 times minus 9 meter. So we have 500 nanometer, and if we convert 500 nanometer into meter, we have the result 5 times 10 to the power of minus 7 meter. Then we have velocity. So velocity is equal to 2 times 10 to the power of 8 meter per second. We have to find frequency, so we don't know frequency. So let's write the formula. V is equal to wavelength times frequency. So we have to find frequency. Frequency is equal to velocity over wavelength. So F is equal to 2 times 10 to the power of 8 meter per second over 5 times 10 to the power of minus 7 meter. And if we will make the calculations, the result shows us that 4 times 10 to the power of 14 hertz. So we reach the result. So we can see that the frequency is equal to 4 times 10 to the power of 14. And let's go back for our example. Let me clear the drawings. So we will see the result equal. So you can see that they are converting the nanometer into meter, and 4 times 10 to the power of 14 hertz is our result. So you may also look for this solution. And dear students, now we have the last example, the last question, which we have to solve with you. So let's first read the example. What is the wavelength of earthquake S waves that travel through rock at 2 kilometers per second with a period of 0.05 second? So again, I am going to my whiteboard. So I'm going to my whiteboard and I'm dividing my board into two parts and I'm writing what is given to me. So given. For the third question, dear student, what is given? The period is given. P is equal to 0.05. So we have to find the frequency. Let's remember the formula. F is equal to 1 over P. So 1 over 0.05, we will have the result 20 Hertz. So we found the frequency. Then, dear students, the velocity is equal to 2 kilometers per second. We also have to convert the velocity for meter per second. Then 2 kilometers over second times 1000, it's meter and it's 1 kilometer. So kilometer cancel each other. Here we will have the result 2000 meter per second. So now we have the unknown things. Velocity is equal to wavelength times frequency. We have to find the wavelength. Wavelength is equal to velocity over frequency, 2000 meter per second over 20 hertz, and wavelength will equal to 100 meter. Yes, it's also not so hard example. We solved and we reached for the solution. Let's go back for our example. Let's go back and check the solution. So here, as you see, F is equal to 1 over period, 20 hertz, then 2 kilometers per second, convert also for meter per second. Then they make the calculation and the result is 100 meter. Dear student, for today's lesson, I want to solve with you some example about wave speed, about wavelengths, and about frequency. And I hope everything was clear, everything was understandable, and we will continue with the next lesson, with the next topic. And if you will have some questions, please write me. I will try to answer you from my channel. So thank you for your attention, and I wish you all